Hi Year 11. This is the video for exercise 2F, absolute error and limits of accuracy. Now there's quite a bit of subject-specific terminology that you need to know. Here they are along the side here. I'm going to go through these as we go through this exercise. So the precision is the smallest unit on a measurement instrument. So on a ruler, if you've got a ruler with little millimeters lines on it, then the precision is to the nearest millimetre. So it really depends on what those little lines represent. In a particular measurement that they give you, I'm going to go through that in the examples, it's to the smallest significant figure that they give you. So we'll talk about that in a minute. So the absolute error is plus or minus half the precision. I'll go over that for you in a minute. And I'll go over those other ones, upper and lower bound, as we get there, because otherwise I'm going to be saying the same thing 20 times. Okay, so in question 5 of the previous section, a steel rod was measured to the nearest centimetre. Hopefully you remember that. Because this was the smallest unit on the ruler, the length was closer to 14 centimetres than to 13 centimetres or even 15 centimetres. The greatest possible error for this measurement was half a centimetre, or half of the smallest scale unit, which in this case was a centimetre, on the ruler. The actual length will lie somewhere between 13.5 and 14.5 centimetres. Okay, so that's give or take minus 0.5 centimetres and plus 0.5 centimetres. So to obtain a more accurate measurement, we would need to use a more accurate ruler, one that has a scale marked in smaller units. Because there is always some degree of error in a numerical value found by measurement, it follows that the results of any calculations involving this value will also contain a degree of error. So here we have the same sort of thing. So what I want you to know, something that most people tend to miss, is when you're working out error, you are going to do the precision of the instrument or the reading, divide that by 2, and then we're going to add or subtract it on to the measurement that we have. So let's have a go at some questions and let's hope this makes a bit more sense. All right, here's the first one. Example 2F1. I'll get a pen up just to be ready. Okay, so for each of the measurements below, find the smallest unit of measurement. So if you read this box here, it says the last significant figure of the number is in the units column. So the smallest scale on the measuring instrument is 1 centimetre. So you basically have to look and see what's the good old place value of the digit furthest to the right. Okay, in this case, it's the units, isn't it? That's the units column. So therefore, the smallest unit of measurement, I, will be, all right, 1 of that column. In this case, that's 1 centimetre. Okay, all right, let's try the next one. Part 2 then says, what's the absolute error? Okay, now remember to work out error, you do the precision divided by 2, or what it says here, half times the precision, and don't forget we're going to do above and below, so that's why we put a plus and a minus in front. So I'm going to take my precision, 1, and I'm going to halve it or divide it by 2, so obviously that means I get half a centimetre. Fractional decimal is fine. Don't forget, my final answer has to have a plus and a minus in front because we've got to go above and below the measurement. All right, next one, 2.4 kilos. So if you read this one here, 2.4 kilos, the last significant figure is in the 10th position, okay, isn't it? So therefore, the smallest unit of measure is in the 10th position. Now the smallest unit I can measure with is the number 1, not 0, because 0 is not a measurement, it's the 1. So I put a 1 in the 10th position. So my smallest unit of measurement is going to be 0.1 kilograms because my question is in kilograms. So now for part 2, what's the absolute error? Well, I take that answer and I just divide it by 2. Do that on your calculator. Oh, that's what I forgot. I didn't bring a calculator with me. And I get 0.05 kilograms. Just check that on your calculator because I don't have one with me. All right, so there's that one there. So now we're going to do pretty much the same thing for question number 1. So here's question number 1. I'll read it to you first. For a measurement given as 138 centimetres, the last significant figure is in the, so the 8 is in the units column, isn't it? Okay, in terms of place value. Bad writing, sorry about that. So the smallest scale on the measuring instrument is to the nearest 1 centimetre. So the measurement has been made, so the smallest scale is to the nearest. That's a bit, yeah, I think they're saying the same thing twice there. Is 1 centimetre, all right, to the nearest, well, the nearest centimetre, I guess, if you wish. Okay, all right, let's hope that's kind of correct. Here we go. So the precision is, goodness me, let's write the same thing 10 million times, shall we? 1 centimetre, so the absolute error will be 1/2 of 1, which is plus or minus 0.5. Please don't forget your units. It's really important that you put those in. Okay, felt like I wrote the same thing 20 times there. Hopefully that makes sense. Question number 2, same sort of thing. For each of the following measurements, find the smallest unit of measurement and find the absolute error. All right, let's do 16 centimetres first. Just going to do it over here. So A, 16 centimetres. So the smallest unit of measure, where's the last significant figure? It's in the units position. So I'm going to put a 1 in that position. So that basically just means 1 centimetre is my smallest. Part 2, I now have to halve that answer, okay, which gives me 1/2. So it's going to be 1/2 centimetre above and below. So put in your plus and your minus, and that's all you have to do there. Now let's try 3.6. So for question E, 3.6 kilos. Okay, the last significant figure is the 6. So that means my precision is to the 10th position, and 1 is the smallest digit, so it's to 0.1. Okay, there's my precision. And now to find my error, I, absolute error, divide that by 2, and I get 0.05. Just make some space for my, thanks, be nice if you worked for me, plus and a minus, and don't forget your units. Okay, all right, let's try the next one. Example 2F. For each of the following, find the smallest unit of measurement, the precision, the absolute error, and the upper and lower bound. So now we're going to work out the plus and the minus, and we're actually going to add and subtract it from the measurement. That's the third thing we do. So here is the think and apply if you want to follow it. So if you watch the think, it says find the precision and the absolute error, as in just as where we have been, but this time actually subtract it and add it to the measurement in the question. All right, let's have a go. So I'll make this bigger so it's a bit neater. So I is asking me for the smallest unit of measurement. So the 16 seconds smallest unit is the units position and place value. So 1 second is the smallest unit. So therefore the error, come on pen, there we go, is going to be 1 divided by 2 or 1/2 second. Okay, don't forget the plus and the minus like I have. Now 3, so adding on to that, take your number in the question 16 and subtract 1/2 second. Take your number in the question 16 and add on 1/2 second. So your lower limit will be 15.5 seconds and your upper limit will be 16.5 seconds. Sometimes this is written like this, just so you know if you see it, 15.5 to 16.5 secs. Okay, or sometimes it's also written as 16 plus or minus 0.5 s. Okay, so if you see either of those two, that's what they want. Now, if they do ask you for the range, you've got to write it like that. Okay, so if the question asks you for the range, please do write it like that. And B, I'll do it in a different colour so you can see it. So B is to the nearest second decimal place, so that's the hundredths position. So my smallest unit of measurement, therefore, is, I put a 1 in the hundredths position. So my absolute error therefore will be half of that, plus or minus, Miss King, 0.005. So if that's to 2 decimal places, my 5 goes in the 3rd decimal place, if that helps you at all. And I'm running out of room, so the 3rd one I'll just write over here. So the 3rd one, I take my measurement and I add and subtract 0.005 from it. So 9.38 plus 9.38 minus equals, so this one hopefully will be just a little bit below, 9.375 and 9.385. So you have just found the upper, this one's the upper limit, and this one is the lower limit. All right, next question. So let's do that again. Number 3, complete the following for a measurement of 2.6 kilos. Okay, precision is to the nearest. It's in the 10th position, the last number, so it's to the nearest 0.1 of a kilo. So therefore the error is half of that, plus or minus 0.05, isn't it? Sorry, can't write that little space. So lower bound will be 0.05 subtracted from 2.6. Upper bound will be 0.05 added. So my measurement must lie between. So 2.6 minus 0.05 is 2.55. And added is 2.65. Don't forget your units of kilos if you can fit them in. Number 5, the capacity of a container. Now, if you want to have a go on your own, can you pause the video, have a go at this one on your own, and then start it again, please, and see how I go. So feel free to pause at any time. Capacity of a container is given at 750 mils to the nearest 50 mils. All right, so this one, when they give you rounding, that becomes your precision, okay? So this has been given to the nearest 50 mils, so your precision is now 50 mils. So to work out the error, you've got to work out half of 50. Half of 50 is plus or minus 25 mils, isn't it? So your lower bound will be lower than 750 minus 25, or 750 plus 25. So the true measurement lies between, make it bigger so it's a bit neater, 725 and 775. Don't forget your units. Okay, hopefully you got that for 5. Okay, here's example 2F3, finding the absolute error as a percentage. So I've also given you a video on percentage error within Google Classroom. So if you'd like to have a look at that too, be my guest. So first of all, think here, I'm reading, it says find the precision and then the absolute error. Okay, and then all you're doing is you are basically putting the error, here it is here, over the measurement that they give you in the question. Okay, can't write measurement. So you're pretty much doing this, and then you're timesing by 100. If you've got a percent key, don't press the percent key. That's just telling you to put a percent on the end of your answer. Okay, that's ugly. That's much prettier, so let's leave that there. All right, so here we go. So find the absolute area for 18 kilos. So the precision is to the nearest unit, isn't it? So that means it is, I'll just write that down again, 18 kilos, because it's off screen for me. So the precision is 1 kilo, isn't it? All right, so to find the absolute error, or just error as I call it, we're going to go 1 divided by 2, so we get half a kilo. And don't forget your plus and minus, like I always seem to be doing. Okay, so now we have to do the absolute error as a percentage. So take your error, remember you're following this formula here. So you're going to go error, plus and minus, don't forget it, over the measurement. What was the measurement in the question again? It was 18. and then times it by 100. Now, unfortunately, I've left my calculator in the other room, so I'm hoping you're going to go and do that for me. Now, I'm just going to stop the video here so I can go and get my calculator. I'll come back and I'll answer that in a minute. Thanks, guys.